We might look at exam questions. Yeah. Yeah, because I kind of really need the double classes for the stuff we're doing right now.
Plus it's the last period in the day.
Yeah, I didn't think it'd be great for more partial fractions. Okay, so if we can look now at page 156, question 2. It's not too bad actually. 2x squared plus 6x plus 5 over x cubed plus 5x squared plus 8x plus 4, yeah? Now, yeah, first thing we should do is factorize there. So what factors do you get?
You get I.
No.
Are you sure those are the numbers?
X plus 1, X plus 2.
Yeah, I copied that right. 1, 5, 8, 4. What do you get?
X plus 1, X plus 2.
X plus 1, X plus 2.
Squared.
Yeah, which one? This one, the 2. Because you need to make a fourth back. Yeah?
X minus 1 and X minus 2 twice.
Now we have 3 ways we can continue. That's the point I'm making in the question. You could say this is A over x plus 1 plus B over x plus 2 plus CX over x plus 2 squared. It's one way to proceed. You could have also have said A over x plus 1 plus B over x plus 2 plus C over x plus 2 squared. Something interesting happens here though. I want to look at this on the side for a moment. So just going to the side. If I have B over x plus 2 plus CX over x plus 2 squared, yeah? I could change that into BX plus 2 over x plus 2 squared plus CX over x plus 2 squared, yes? Which means I could put it all over x plus 2 squared. This is linear. This is linear. If I add them together, what do I get? Linear plus linear? No, plus. Linear plus linear, not multiply. Linear. So the top here would be something like EX plus F. Because you're just having BX plus 2B plus CX. Yeah?
Just one question. How did you go from B to BX? How did you go from X plus 2 go?
I multiplied above and below by x plus 2. The point I'm trying to make is that these two guys can be represented just as well as one fraction, but with a linear on the top, b plus c, or well, if you use a different letter, whatever, ex plus f.
Just make the denominator.
Yeah. So if I go back now to the question, it means that here I could have also said a over x plus 1 plus bx plus c over x plus 2 squared. So you have 3 choices here, and you'll get 3 different answers. But each answer will simplify to the same thing, even though they look quite different. Okay? So I don't know how much more you need me to continue, because now at this point, it's just use whatever method you like. I think most people in the last class were using method 2 for this one here. So you have 3 problems you need to solve.
Is it 2 dissolved in the C?
One sec, sorry. Okay, what were you saying?
Is it 2 dissolved in the C?
This one here?
And
This one here? Yeah. You're unhappy with this b, is it? Yeah, it's like it absorbed it. If you don't like me using b and c, you can just use e and f. Like they just stand for some constant, you know. Yeah, it's not like there's anything special about them. So I mean, you could have just said p, q, r, like whatever, you know. We just want to get the form correct, the correct form. Yeah. So we could use method 2 on all three of them. We'll get the answer. Who was asking me this one? It was you, wasn't it? So do you want to see one of these, or what's the story?
Can you do the third one?
The third one, yeah, because that's a bit different. So let's look at answer 3. So I'll just go back here and say 2x squared plus 6x plus 5 over x plus 1 times x plus 2 squared equals a over x plus 1 plus bx plus c over x plus 2 squared. Yeah, we'll multiply everything by the denominator here. So we'll get 2x squared plus 6x plus 5 equals a times x plus 2 squared plus bx plus c times x plus 1. Okay, so who can tell me what I should choose for x? Choose x equals what to start? Any ideas?
1 second. Wait.
Yeah? What should I choose? And what would that give me? That gives a. If you sub in minus 1 here, you can get a. Yeah?
I don't think you can.
Yes, you can.
But wouldn't that mean that isn't x of the limit or something? I'm not thinking properly outside. But wouldn't one, if you look up, a is over x plus 1. If you see that, it's
No, look at this. No, dude, we talked about this in class. I said I don't like this method because you have to use values that you're not allowed to use. And I said it only works for this problem. It's breaking my heart.
It's not Monday. It's not Monday.
Breaking my heart. Yeah. Do you want to break my heart as well? Why did I choose? Well, she chose it. So ask her. Why did you choose minus 1? Speak up there. What are you saying?
Is it because you're not supposed to use the value of the one you should use to find the coefficient?
Okay, you don't know. So the reason you choose is because the last bracket, yeah.
Yeah, that's right.
Well, basically, yeah, you want to make this guy 0 so you can just be left with a. Yeah. And you said it so well, too. Okay, what should I choose next now? Choose x equals what? Yeah, no. Because that would give you an equation that has b and c in it. No.
0.
0.
C.
0. Because if you put in 0, what could you get?
C.
You could get c. Yeah, very good. Gives you c.
Because that cancels a.
It can't. No, the a you already worked out.
Oh yeah.
And the 0 cancels the b, leaving you with only c times 1. So you can get c quite easily. Right, now lastly, it doesn't really matter what you choose for the last one because you already have a and c. So anything will work to give you b. That's how you can get the b then. Because you already have a and c. Yeah? What's up?
It's kind of similar to the third method.
The cover-up method, the third method.
Where you use the values of the variable.
It's similar in the values you choose, isn't it? Yeah, yeah.
Would both work for this one?
I'm not sure if the cover-up method works so well here because of the bx plus c. I know for a fact that the cover-up method works when the numerators are all constant. So which form here could use the method tree? You could use method tree on the second one here, possibly. Possibly. Although you might have a little bit of a problem with the x plus 2 squared, yeah, so we're not even sure. But you can certainly use method 2 on all of them. And why should you not use method 1?
Too long.
Yeah, because what will happen?
It will never end.
Oh no, it will end. It will end. Why not method
It's a
1?
figure of speech.
Yeah, why not method 1? No, method 1 produces simultaneous equations for you to solve.
Oh,
And you'll have a simultaneous of ABC to solve. So when you consider all three methods, method 2 is the most reliable method for finding an answer easily enough.
Well, couldn't you find A in terms of...
You could, no, but it's not that it's impossible, it's just what is quickest and safest and most reliable. I think it's probably the second method. Yeah. Now, I want to show you something here, and then we'll look at that question in a moment. So, can you look at the answer at the back? You see there are 3 answers here on question 2. Now, you might be surprised to think that those 3 are actually all the same thing, because they look quite different, don't they? Not only are they, I'm not saying that they're similar, I'm saying they're exactly the same, just in different forms. And I want to show you that by showing you what happens if you add the 3 of them together. In each case, you should get the same thing, if they're supposed to be the same. So I'll do that now. Here we go. So the first one was 1 over x plus 1, plus 1 over x plus 2, plus minus 1 over x plus 2 squared. When I add these 3 together, let's see what I get. I get this. Was that the original question? It was. Yeah, except, of course, for the denominator, but it's the same thing. So we agree that this is a correct representation of the question. Right, well, let's see the second one. 1 over x plus 1 plus a half over x plus 2 plus a half x over x plus 2 squared. Right, let's add these together now. And we get the same thing. So again, this is a correct representation of the question. Yeah, I know, I find this really strange that this actually works, but it does. X plus 1 over x plus 2 squared. Let's add these 2 together. And again, it forms the original question. So amazingly, these 3 different representations, they all equal the same thing if you were to add them together. Which the first time I did this, I didn't believe it, because I couldn't believe that these 3 are actually the same.
Wouldn't getting the 0.5 as a numerator be weird?
0.5? What's wrong with that?
Wouldn't it be weird?
No, sometimes in the exam the A, B and C's could be fractions. They're usually not, but they could be. They could be.
When was the last time you
I don't know, like 2 or 3 years ago. It does happen. So don't necessarily think you got it wrong just because you got a fraction. Usually it's a whole number though, but you know, if you got a fraction, just double check, and if it's still a fraction, then you know, it could be right. Yeah.
Because I would think I would be wrong.
Yeah, no, and that's fair enough because they're usually an integer. Are we okay with this now? It is quite interesting that those 3 are the same, isn't it? The reason we care about partial fractions is because we want to take something complicated like this and simplify it into 3 simpler terms. So in your opinion, which of the 3 forms here is the simplest representation of this?
Number 1.
I would go with number 1 because all the numerators have just 1 in it. Whereas here, this is a linear, and here this is a linear. Yeah?
I'm saying the third one because if you cross multiply, just make x plus 2 squared equals x plus 2 squared.
No, but what I meant was which would have easier individual parts. So I think we can see each of these as quite simple compared to maybe this guy or compared to this one here. You know, so we would choose this form to represent this. So if I write, 1 equals 4 here. I'm saying that these 3 guys equals that. Yeah? Okay, so the next example I want to do is an extremely hard integration by parts.
152,
152.
the last one.
Yeah.
Such an ugly question. Such
Very
an ugly
tricky.
question.
Very tricky.
Let's find
Does
the
it get
result.
this hard in the exam?
No, but it's an excellent. If you want to do just one question from that page that makes sure your integration is perfect, it's this one. Because if you can successfully do this one, it means you've mastered the topic.
The order.
Yes, indeed. Yes, indeed. Okay. No, it's too hard for the exam, but it's an excellent study question. Yeah. All right, let's have a look at it. So the question is integrate x over x squared plus 4x plus 8 dx. And I give you a hint. I tell you to consider it as a problem like this. Integrate x times 1 over x squared plus 4x plus 8 dx. And I tell you to use by parts. So that's how you can get the ball rolling on this to begin with. Okay. Right, so if we're using by parts here, we use our usual box here. F, what's F here? X. F derivative? 1. G derivative is that guy. That's G derivative. So what's G? Now, yeah, what is it?
Take it up to the minus 1 and
No. That's what Amjad said as well. Not this. So the problem is,
why am I disappointed with that?
the problem is we need to figure out what the integration of this is, right, to get the G, to go up here. So what we have now is a new side problem. If we go to the side, we now have to figure out what does this integrate to. Yeah? This is F derivative, G derivative, so what the heck is G? So now we scroll to the side and look at a side problem. So in red here, we have to figure out what is the integration of 1 over, what was it, x squared plus 4x plus 8, wasn't it? What does this integrate to? Yeah? Who remembers what to do here? No, that's for derivative, quotient rule.
Substitution.
Not this time because of the numerator.
Factorize.
No factors for the quadratic. Not log, because log is only if it's linear. Yeah? Factorize, no factors. Yeah, but how? We're having, like, so factorize, no good, because there's no factors.
Divide them.
By what? Yeah. Yeah? Nobody remembers what to do?
Wait.
No.
Wait.
It's not coming. Nobody has it.
Give me 10 seconds.
All right, 10 seconds. Then I'm saying what it is. Yes.
Divide the denominator so 10 cancel it, right?
No. Nice try.
Ration.
That was the very first suggestion that he made, and not true.
Ration clouds.
No. So what you have to do is to complete the square. That's x plus 2 squared plus 4, which is 2 squared. Yes? Do you remember doing this in class?
Yes.
And now, what do you make u equal to?
X plus 2.
Nope. Come on. This means you've all forgotten this lesson.
X plus.
U equals, yeah?
U equals
X plus
No.
2.
minus 2.
No? It's equal to x plus 2 over 2. Remember, square root the first over the second. Oh yeah, that thing. So that's u, or in other words, if you like, that's a half x plus 1. What's du dx? Du dx here? 1 over 2. The derivative here. So, what does dx equal? What does dx equal? Come on, come on. Are you sure? Yeah. Yeah. Or in other words, 2 du. Yeah. Okay, so let's go back here. That's equal to 1 over. Now look here, make it a little bit clearer. This line you can say 2u equals x plus 2, true?
Yes.
So x plus 2 squared would equal 4u squared. So that means the x plus 2 squared here is 4u squared plus 4. 2 squared. And dx we said is 2 du. What can I cancel here? What's in common?
The 2.
The 2. So that's 1 over 2u squared plus 2 du. And what's in common here?
2.
The 2. So I'm left with 1 over 2 integrate du over u squared plus 1. What does that equal? What's 1 over u squared plus 1 integrated? A half. What's this one? Come on, guys. What's this?
Du over u squared plus 1?
Yeah, what does? Come on.
u3.
No. Oh, dude, it's tan inverse u.
Oh my god, my brain has just...
Yeah. So that means you get a half tan inverse x plus 2 over 2.
You're catching this on a bad day.
Oh.
Indeed.
Bear in mind, we had to wake up early for submitting the English reading.
Yeah, but like, it's half 2, you know, not 7 p.m. So we should still have a little energy left in the tank.
0 energy.
Okay. Back to the main question.
Yes.
So, we've successfully worked out the integration. Let's not forget what we were originally doing. We successfully worked out the integration here of 1 over x squared plus 4x. So we can snap back to the main question. And we said this is a half tan inverse x plus 2 over 2. Yeah? Focus. You're not even writing anything. Come on, focus. Okay. So that was a side problem. Now let's go back to the main integration. So the rule is f g minus integrate f derivative
Over G.
times g. So f derivative is 1. So that's, I'll take the half outside, a half tan inverse x plus 2 over 2 dx. Right, now I have a new side problem. I have to integrate tan inverse x plus 2 over 2. What?
I have a question for you.
Now, it better be good. Is it good?
I'm really sleepy, so it might be bad.
Okay.
But like, I'm gonna give it my best.
Go on.
Why didn't you choose x as the g?
Yeah, it's the rule L. No, because in the question I tell you. That's the only reason. In the question I tell you which way around to do it.
You said hint and then you gave us that.
Yeah.
But that does not mean that it couldn't be GF.
No. The hint was trying to correctly give you. Yeah. Yes. Yeah. No. If you swap them around, I don't even know if you could do it that way.
But I'm just thinking about it.
No, dude, stop. Just trust me. I gave you the hint. It needs to be this way around. Trust me on it. Trust me. If you don't want to trust me, that's fine. But you should trust me. Okay. Continue with the side problem on the left now. So off to the left we go. And we need to integrate tan inverse x plus 2 over 2 dx. So what is the technique here? What do we do here? Yeah, so what should we make u equal to? X plus 2 over 2. So that means u equals a half x plus a half. So what's du dx? A half. So what is dx? 2 du. So this becomes integrate tan inverse u, isn't it? Yeah. Times 2 du. So let's just get that 2 out in front. 2 tan inverse u. We're trying to integrate du. Okay. Now we've got a new side problem. We have to integrate tan inverse u. Yes? So, onto the side again. Who remembers? Now we did this one in class. We did exactly this one in class. Who remembers what to do here? Cos? No. What is it? No.
Isn't it 1 over 8?
No. You don't really remember it if you go back to your notes to check. All you've done is remembered that you wrote it down. Does anyone remember? You're not remembering, you're reading. No. The trick here is you put in a second function called 1 and you make it now a by parts problem. We did this exact one in class. So, off we go again. What's f here? Tan inverse x. Yes? And what's f derivative? Now this is in the formula book. The derivative of tan inverse is in the formula book. 1 over x squared, yeah, plus 1. Okay. Yeah, we're using the letter u in the previous one, aren't we? G derivative is 1 and g is x. So this is equal to fg minus integrate f derivative. What's f derivative here? 1 over x squared plus 1 times g, which is x. Okay. Side problem. So now we have to integrate this. Yeah? Yes, but you're going to miss so much, you know that.
Wait, isn't this half sine plus cos?
No.
Or is that a different version?
Problem? That's the rule. Fg minus f derivative g.
Isn't the whole answer half sine cosine?
Hang on, one at a time. I'm pretty sure the formula has a minus in it. And if you wrote down plus, that's a problem. I'm pretty sure it's a minus. Did you write down plus? Maybe. Okay, continuing on the side, a new side problem. But I promise you this is the last side problem. So we have to integrate x over x squared plus 1 dx. How do we do that? U equals x squared plus 1. Good. Du dx? 2x. Du equals 2x dx. So dx equals du over 2x. So this is integrate x over u, du over 2x. And this is nice.
X goes with that.
X goes with x. It's half integrate u du, which is what? A half log u, which is equal to a half log x squared plus 1.
Don't you mean 1 over u?
Oh, sorry, yeah, thank you. That's 1 over u du, which becomes then log u. Right, so you've all seen that movie Inception, haven't you? Yeah, so we're at the stage of the problem where you wake up from dream level 3, back up to 2, back up to 1, back up to the real world. So that's what's going to happen next. Can I start moving up levels? So this integrated to a half log x squared plus 1. So we go across here, which means that integrated to a half log x squared plus 1. Isn't that what I just said? Yeah. Right, so now we have to go back here. The reason we needed that was because we had this tan inverse u problem here. So that is equal to 2 bracket this one here. But we're using the letter u instead of x. So that's u tan inverse u minus a half log u squared plus 1. But u is x plus 2 over 2. So that's 2 x plus 2 over 2. Cancel, cancel. Tan inverse x plus 2 over 2 minus a half log x plus 2 over 2 squared plus 1. Okay. Why did we need that? Well, because we needed to integrate tan inverse x plus 2 over 2. So this is equal to x over 2 tan inverse x plus 2 over 2 minus a half of that thing there, which is x plus 2 tan inverse x plus 2 over 2 minus a half log x plus 2 over 2 squared plus 1. Close. Now, let's clean this up a little bit. So, both these guys have a 2 in them. So let's just take out the 2, firstly. So that would be x tan inverse x plus 2 over 2 minus x plus 2 tan inverse x plus 2 over 2 minus, now I gotta get my signs right, minus, and minus minus is plus here, isn't it? A half log. Now if we expand this, what do we get? We get x squared plus 4x plus 4 over 2 plus 1. Now these two guys actually go together. What happens here? What's x minus x plus 2? Come on, x minus x plus 2. 2. So you get 2 tan inverse x plus 2 over 2 plus a half log x squared plus 4x plus 4 plus 2 all over 2.
Is it over 2 or over 4?
Thank you, over 4. So that would be plus 4 at the end then, if I add the 1 in. Okay, last step now. Let's multiply in by the half. So that would be tan inverse x plus 2 over 2 minus a half log x squared plus 4x plus 8 over 4. That equals tan inverse x plus 2 over 2 minus, now if you want you can put the, well what I can do is use my rule that says log a over log b is log a minus b, so that's plus a half log 4. The reason I'm doing that is because there's a plus c at the end, so I can just absorb that constant into the c. So my final answer is tan inverse x plus 2 over 2 minus a half log x squared plus 4x plus 8 plus c.
The only way you solve it correctly here is with your
My signs are backwards. Oh well.
Who
Boom.
asked you to do this question?
What do you mean
Who
by
made
national
this question?
Denver 2017 students?
Why is it?
I swear to God,
They-
the guy
they-
who
it
made
was,
this question is a bit on crack.
Yes, I'll tell you why. No, I said that at the very start.
Did you write this question?
Yeah, I did.
Were you on drugs when you
No,
wrote
no,
this
no, no,
question?
no, no. It's a brilliant question. I
What
love
do
it.
you mean brilliant? What do you mean brilliant?
It's brilliant.
It's-
Now, wait, I'm thinking.
Where did you make him stick in the signs?
Serious.
Yep. So let me just type in. Well, maybe my answer. What was the question? X over x squared plus.
Didn't you solve this earlier today?
Yeah, but not fully. Do I have? Yeah. So I've lost in somewhere in my dream world. I've lost a minus somewhere, and it flipped the signs around.
Isn't it the line before your answer? It is divide, isn't it
Oh yeah, it is minus, but that doesn't fix my problem at the end though. No, it's minus minus, so it is plus. Minus plus.
I think I see it.
Yeah.
3 lines before the end.
1, 2, 3. Yeah, it is. Sorry, you're right. Yeah, x minus x, but the plus 2 is inside the brackets with the minus. So that should have been a minus 2 there. So that's a minus, that's a minus, that's a minus. But this guy should have been a plus.
No, but like
Oh, because
it was
there's
a plus.
It was a plus, and I just magically
Yeah.
changed it. Plus, plus, plus. So that's now, it all makes sense now. So minus tan inverse x plus 2 over 2 plus a half log x squared plus 4x plus 8 plus c.
Did you just rewrite the last line all over?
I
But
did, for fun. There you go. So, there you go.
So what do you mean by the comment after that?
Yeah, this question came about because if I just go back to the original questions, zoom back up to real life. What happened was I was doing this question in class, where the only difference was it was a plus 2. And somebody was doing this question, but they left out the plus 2 or something like this. And I said, oh no, I don't know if it's possible to solve it without the plus 2. So I was thinking about it, and I realized, okay, if the 2 isn't there, could you solve this? Well, if you do this, and then if you do this, and I'm like, oh, I like it. So the point is, if I just write a plus 2 here, you might think that doesn't change the problem much, but it actually changes a lot. Because if you had this question, it's much easier. No, you just say u equals x squared plus 4x plus 8. What does du dx equal? It equals 2x plus 4. So dx equals 2x plus 4. No, I wrote that the wrong way around. Du equals, oh, for flip's sake, dx equals du over 2x plus 4. So this question here would become integrate x plus 2 over u du over 2x plus 4. But 2x plus 4, you take the 2 out, and then what happens? Cancel cancels. That's a half integrate 1 over u du. So the answer is a half log x squared plus 4x plus c plus 8 plus c. So the point is, although it looks extremely similar, simply deleting this 2 made the question much harder.
Oh,
much harder.
It's a very big understatement.
If this question was to come in the exam,
It would not come up in the exam.
like let's just say, how many
No,
marks
that's
do you
not
get?
even worth saying if. Because there's no way it
This
could
is
be.
like the whole
Just
exam.
looking, I'm trying to like understand the value of the question. Like how many marks would it?
20.
20?
20.
What? It's
So
not
like a whole
worth
big
20.
question.
Yeah, this would be a whole big question.
I think this would be more than 20.
And what they would do, it would be, if it was, guys, if it was ever to come up in the exam, it wouldn't just be, here's the integration, integrate it. What they would do is, there'd be something like a part A, integrate this. Part B, integrate this. Part C, integrate this. And then part D, therefore, integrate this. And you use the previous 3 answers, you know.
So what they do that?
The
I'd say highly unlikely.
people who write the exam, in my opinion, don't have the same level of imagination that I might have for writing exam questions. No. No. They wouldn't have this in the exam. It's just way too difficult. And if they ever did, it would have to be staged as a 4-part question.
I genuinely think you're on some type of.
No.
I hope it's a big question so we can skip it.
The B integration is not as hard as this. Really, it's not. Yeah?
So that you smoke some weed and you're overthinking about it.
Yeah, and even if it did, it would have to be staged as 4 questions. Step by step. Yeah. Yeah. Because you realize each individual part is something we've already done.
Yeah.
Like, we've done integrate and tan inverse. We've done integrate and this. You know? Okay. Right. that was good.
No, that
Like I said, if you the reason this is the reason that this is a good question is because if you did this question, you would be revising many worksheets in one. For example, this one here was from page 150. Then this one over here, this was from page 148. This one here was from page 152. And then this one here was from page 148 again. You see what? And then the actual main question is a by parts, so that is also another revision of 152.
it's a good question.
And you realise I could do one little thing even to make more. I could just also stick in limits. There you go, 1 to 2. So it means, and they do this in the exam sometimes, they would ask you to put in limits here of 1 to 2 and to give your answer as an exact answer, not as a decimal, which means now you have to use the rules of logs. So that would be page,
What type of demon is this?
that would be page 50.
And then they keep the line.
Graph it as well.
Not graph it. Not graph it. No.
Always goes first.
And lastly, I'll ask you,
Sir, don't think of it anymore.
Yeah, can you just stop talking about
no, okay. You could. But then, I could put a very small question at the end for like 1 mark. I could say, y equals this, where's the turning point?
I will give
No,
up.
sit.
Can I just do it?
No, sit. Y equals this, where's the turning point?
You have to complete that whole thing.
No, yeah, the whole thing, where's the turning point? What do you have to do to find the turning point?
You have to find a C.
No. Oh, well, forget about the C. Where's the turning point? Oh, you don't even need to find the C, actually, to get the turning point. So how do you normally get the turning point? You differentiate. But you already have that answer, because at the very top, remember, if we go down, and that's integrate, and then it means going backwards is differentiate. So what is the derivative of this whole thing?
It's X.
It's the original
X squared plus 4x.
x plus 2 over x squared plus 4x plus 8. When is that 0? Only when the top is 0. Which is when?
When x is minus 2.
When x is minus 2. So you could say, oh, this has a turning point at minus 2.
Wait,
Oh wait, but the question
no,
was X.
no, the question was X.
X
It was
plus
X
two
plus
Oh,
was
fine
zero.
then. If it was x, then where does it have the turning point?
0.
At 0. Yeah. And is it okay to put 0 into this? It is, because that's fine, isn't it?
Yeah.
And that's
Half in 8.
a half log 8, so that's fine. That's fine. So, for next year, what I'm going to do is in the workbook, put another question and put limits in. Just to
Then
add
you
an
can
extra level. And then I can
thanks
thank this
to-
group
yeah.
then.
I
yes.
think you've talked to yourself. I genuinely think like you've maxed your potential.
No, no, there's still more that can be done here, I'm sure of it. Alright, we'll
You can just put limits on it and then not
yeah, but I also like this stationary point thing too.
Graph this.
Graph it? Nah, that'd be
Sir,
too
can you
much.
remind me again,
Why are you here?
when do we complete, like,
Completing the square is only for quadratics.
When they're in the denominator, yeah?
No, if you want the turning point, the only time completing the square works is for quadratics. Everything else you could just use derivative.